So moving on, then it's important to note that simultaneously, inclusion is not a new relation. It's just a parsing out of a long relation that has belonging. And then also the power set necessary, and this is on 83, 84, this power set necessarily entails a metastructure by the decision of the axiom of the power set, and that entails that there are two distinct sets, and which is to say the set of A and the power set of A. So basically what we've got here is the power set, because of the axiom of extension, right, which is if a set has all the same elements, then it's the same set, right? They're the same. Well, the fact of the matter is the power set of A is not the same as A, right? It's the things included in A. So let's go back to it. The set of the United Nations includes as an element Ban Ki-moon, right? But the power set doesn't include, or doesn't, sorry, I need to get my verbiage precise. The United Nations has Ban Ki-moon as an element. Ban Ki-moon belongs to the set that is the United Nations. However, in the power set of the United Nations, Ban Ki-moon at best is included through the set, right, the subset of United Nation personnel. So United Nation personnel is an element of the power set, but it's not, sorry, I'm trying to gather my thoughts. It's an element of the power set, but it's not necessarily, the personnel is an element of the power set, but that doesn't entail that Ban Ki-moon is an element of the power set, right? So Ban Ki-moon can be an element of the personnel, which is then an element of the power set of the United Nations, but that doesn't entail that Ban Ki-moon, right, is a direct element in the power set of the United Nations. Is this?
I mean, is it the essential difference between he is included in the set, but he doesn't belong to the set?
Exactly.
Okay.
Does that make sense?
Yeah, and I think that's the distinction that needs to be made. Whenever the E is being written, right, it means belongs.
Right.
But the other one, this half symbol, right, is the include.
Right.
Right, and of course this is what he's elaborating is, in pure set theory, there's no difference. But as we move forward, right, when we start dealing with metastructures, there is a division between belonging and included.
Well,
of course he elaborates.
I'd actually qualify that. What he says is there's no ontological difference between belonging and inclusion.
Yeah.
But later, and this we'll get to this as well, especially with the theorem of excess, what's important is because the metastructure isn't fundamental, it can't be something different in ontology, this reintroduces the errancy of the void in the difference between belonging and inclusion, between elements and parts.
A distinction very much worth making.
Okay, so, do you have a question? Okay, so let's move on to the theorem of excess, which is where a lot of this turns. Let's see, I'll just do it on the side here. So for the theorem of excess, Badiou asserts that the power set stands in absolute excess to the situation, and of course he demonstrates this through the theorem of excess. And this is again 84 to 85. And what we have is that gamma, this is way too big, is equal to, and then we have our curly brackets, we have beta, and then this is basically a way of saying what is included in beta.
The set of beta such that beta belongs to A.
Such that beta belongs to A, or alpha, and this is an important thing. And
That's an ampersand, right?
yeah. Not so here's an important distinction which he actually goes through, and he actually lays a sort of mini topology of sets here. Okay, so what we have is that for gamma, it is such that for a beta, beta is an element of A, and it is not an element of itself. So he makes this distinction between two sorts of sets. There are the sets that are normal or ordinary, which do not belong to themselves, and then there are the evental sets, and those are sets which do belong to themselves. So what we have here with the theorem of excess is it entails, right, just once again, gamma cannot be an element of itself, because in order to do so, this inclusion would be a radical gap in belonging, right? Essentially what he says. And so, so yeah, this is basically where he's coming from this. But then he also moves on. So this is our basic formula. Then he begins applying it to the void, right? And in part 3, or not part 3, in subsection 3, the void and the excess. So he goes on to argue that the void is a subset of any set, and also that the void possesses a subset, which is the void itself.
Can we actually back up for 1 second? So
Sure.
he makes this, the equivalence for y of y belongs to, or sorry, gamma belongs to gamma, the evental, and that gamma does not belong to itself, the ordinary, is a formal contradiction. It obliges us to reject the initial hypothesis, thus gamma does not belong to alpha. Sorry, that's on 85, it's like halfway.
Yeah. Oh, do you want to run through this argument?
Just wanna, yeah, back it, yeah.
Okay, so basically what there is there's a hypothesis that is then rejected. So what we would do is, let's presuppose for the moment that for gamma is an evental site. So,
Gamma will belong to itself.
yeah, so let's go with, let's see exactly how he does it. Does he formally parse it out, or does he just,
Consequently, there's always whatever alpha is, at least one element here, gamma of the power set A.
Okay, so yeah, so what we would have is, we'll just use it as beta, because that's how it's parsed out here. So what we would have is, beta is an element of itself. Okay, so what happens? We replace this A, right? And what we have is beta, right? But this is also a unitary relation. So what do we have? Beta is an element of beta,
And beta does not belong to beta.
and beta is, well, no.
Beta is not included.
Beta is not an element of beta, because those are two different things.
Yeah.
Right, yeah, it's,
Yeah, so, yeah, it is not the case that beta is an element of beta. So what we have here is a formal contradiction,
Yeah.
right? Which, because it's a formal contradiction, he rejects it, right? Which is why,
does it reject, oh, okay, but this leads into later when he talks about, what he makes the distinction.
Right.
Oh, it's, no, it's the, what is it called? It's, he goes off the, ex falso sequitur quota libida.
that's actually something different.
Okay,
That's from the void. That's out of nothing, anything follows.
okay,
But in this case, right, this is the reason for rejecting this.
okay.
This formal contradiction. This is why you reject evental sites in the theory of excess.
In the theory of excess.
In the theorem of excess.
Why would Badiou point this out?
Well, there's a couple reasons. The first is, if you allow for contradiction, then anything follows.
Right, that's the, how it goes.
Right.
Please.
Well, okay, so what happens is, if anything follows, then basically your entire consistency of set theory disappears. Right? I mean, this is what happened initially very quickly with Cantor, right? Cantor posited sets as concepts and thoughts. Well, very quickly, you know, does the set of all thoughts include also the things that are unthinkable, to put it really coarsely? That contradiction explodes Cantor. You have Frege and Russell who come and try to save it by suturing it to language. But then you have Russell's paradox, right, which then renders language inconsistent. So what happens is, if you allow this, what happens is the entire ontological structure of set theory is once again rendered inconsistent. Does that make sense? However, there's something interesting about this. You'll notice it's called being an event, and he names those other sorts of sets, evental sets. Does that make?
Well, I mean, you have the distinction between beta belonging to beta, the set of beta, as the mental set, but then
Right.
beta not belonging to itself as the ordinary set.
Yeah, that's what I'm saying.
Okay.
is, he makes a distinction, he calls it an evental set,
Okay, yeah.
which in a book called Being an Event is going to play a large role.
Right,
Can
But-
you,
I appreciate that, but also the point I'm making is you said he rejected this in the theory of excess, so I'm sort of,
No, he doesn't reject the theory of excess.
sorry, the theorem,
So,
in the theorem of excess, he rejects the evental sets.
that's correct.
Okay,
Okay, because ontology demands its own consistency,
okay,
right? But the question is, are there events which will become clear later, are there events in ontology? That's a different question from are there events?